Continuation for Chemistry MYE 24-25, question number 26. Boron trifluoride, or BF3. It's a simple molecule. So we're talking about covalent bond here. There are 3 covalent bonds in each BF3 molecule. Each of these bonds is made by sharing 1 electron from the boron atom and 1 electron from the fluorine atom. So let's try to write the Lewis structure for this. First, boron is in group 3. So it means boron will have 3 valence electron, while fluorine is in group 7, so it will have 7 valence electron. So we have 3 fluorine. I'll just copy this and this here. Okay, let me change the single one. Okay, so 7 and 7. So it says here that they share 3 covalent bonds in each BF3 molecule. So each of these bonds is made by sharing 1 electron from boron atom to 1 electron of fluorine. So it means this are the shared, 1 from each. Okay, so those are our band. So if you're going to look at here, our fluorine will form 8 electrons, each of them. However, if you're going to check, our boron will only have 6 electrons. So, what is unusual about this bonding? It is unusual for nonmetals such as fluorine to form covalent compound. This is not correct. This is not correct because fluorine is nonmetal and covalent compounds are compounds that are formed usually by 2 nonmetals. The fluorine atoms in each molecule do not gain electronic configuration of a noble gas. So this is also incorrect because as we have seen, the fluorine here has 8 electrons after the sharing. Letter D. The covalent bonds do not consist of shared pairs electron. This is also incorrect because that's the main difference between covalent and ionic. In ionic, they transfer the electrons, while in covalent, they share pair of electrons. And letter D, the boron atom in each molecule does not gain the electronic configuration of the noble gas. So this one is our correct statement because our boron has only 6 electrons in its shell after the sharing. Question number 27. Which of the following shows the outer electron arrangement for magnesium chloride? The key is that for the magnesium and X for chlorine. So let's write first the chemical formula for magnesium chloride. Magnesium is in group 2, so therefore it will have a charge of 2 positive, while chlorine is in group 7, therefore it will have a charge of 1 negative. So their chemical formula will be MgCl2. So we're expecting that there should be 2 chlorine on each in our structure. So our possible answer is A or B. Now C and D are not the answer because magnesium chloride is ionic. So this one shows sharing of electrons, which is a covalent compound. So that's not how we show the charge or the structure for magnesium chloride. Magnesium chloride is ionic. Now, when we show the structure, we need to see that magnesium loses 2 electrons. Once the magnesium loses 2 electrons, it will form a 2 positive charge, and then its outer shell will be consists of 8 electrons, and those electrons are completely all from magnesium, so it means it should be all that. That's why these X's here are wrong. Therefore, the correct answer is letter A. Now, you also need to check that the chlorine should have a negative charge. So if it has a -1 charge, it means it accepted 1 electron. So if it accepted 1 electron from magnesium, you will see 1 dot from each. So this is the 1 dot we can see. Okay, so that's why our answer is letter A.